Target 7.3 asks you to convert between moles of one substance to grams of another. Your strategy is still going to be the same. You're going to highlight what was given, 6.5 moles of Fe2O3. And you're going to highlight what I'm asking for. So in this case, I'm asking you for grams of CO2. If you're using your foldable book, we started with moles of A, and I'm asking you to find grams. So my foldable, I'm going to open that first flap up, and you'll see that your railroad is going to have essentially 3 tracks. You're going to start with your given. You're going to multiply by the mole ratio, and then you just need to add one more step, which turns your moles of what you want into grams. And to do that, that means you have to find the molar mass, and you multiply by the molar mass in grams. Question 1 says, how many grams of CO2 are produced when 6.5 moles of iron 3 oxide react? So in this example, you can only deal with 2 parts of that equation at a time. I only need to look at the CO2 and then the iron oxide. Start by writing down my given, 6.5 moles of Fe2O3. I'm starting with moles. I don't need the molar mass of that iron oxide. The first step is to convert moles of iron oxide into moles of carbon dioxide using my mole ratio. There are 2 iron 2 oxide for every 3 carbon dioxide. From here, if you stopped right here, your final answer would be moles of carbon dioxide. This is what you were doing in target 7.2, converting from moles to moles. I'm not asking for moles, I'm asking for grams of carbon dioxide, which means you extend your railroad one step. And we need to put on the top the grams of what I want, which is the molar mass of, in this case, CO2. So if you want to put a note on your book of how to find that, it's 1 carbon plus 2 oxygen. If I look at the periodic table, carbon has a mass of 12, oxygen has a mass of 16. So 12 plus 16 plus 16 is 44 grams of carbon dioxide in 1 mole of carbon dioxide. So multiply across the top, 6.5 times 3 times 44. That's 858 divided by 2 times 1, which is 2. And I have a final answer of 429 grams of CO2. Question 2 says, if 14 moles of carbon react, how many grams of iron will be produced? So I'm looking at iron and carbon. I can ignore the other 2 parts of that balanced equation because you can only work with 2 things at a time. So 14 moles of carbon is what I'm starting with. That's my given. The next step involves my mole ratio. There are 3 carbon for every 4 iron. If I stop here, that would be a mole to mole conversion. But I want grams, which means I need the molar mass of iron. Iron has a mass of 55.8 grams in 1 mole. Multiply across 14 times 4 times 55.8, 3,124.8 divided by 3 times 1, and I get a final answer of 1,041.6 grams of iron.